where it's given that the coordinates at any time t of a moving body are given by x equal to ct square and y equal to bt square, right? So even I put a sorts of this, but let me explain it over here again. Okay, now here in this question the coordinates are given to you, right? So what we will do, you can see. Okay, so just plot the x and y axis, our xy plane. Okay, if this is the xy plane, right, this is towards x and this is towards y, then you can see this will be the origin. And if the body is given into this numerical, let's say the body is present over here. Okay, the coordinates are x and y. The first is abscissa, second is ordinate. The x and y coordinates are given to you, right? So that means this point corresponds to x, and when you draw this line perpendicular to y, this point corresponds to y, right? It's given that in this question body is moving. Okay, the body is moving and this is the plot of the body at a particular instant of the time. Okay, so this is the body. Okay, right? Now it's given that x equal to ct square. The value of x is given to you as ct square. That means this point is ct square. ct square, right? And the y coordinate is given to you as bt square. That means this point is bt square, right? Now what we will do, we need to find the speed of the body. So what is the speed of the body that need to be calculated? Speed of that moving body is what? The only option which is given to you, the coordinates of that particular moving body, this is the body at a particular instant of time, right? So this is the x and y coordinates given to you. Now you need to find the speed, right? The speed of the body can be simply calculated by dx by dt, right? Isn't it? Because this is the x coordinate ct square, right? And it's also given that y coordinate is bt square. Y coordinate is given to you as bt square, right? Now speed, the x component of the speed will be d by dt of what? X. So let me change the pen so that you can understand very easily. This is for the, we need to differentiate it with respect to x for the x component, right? So this will give you the x component of the velocity. Similarly, when you differentiate with respect to t, the y component, again changing the pen so that it will be easily visible, right? It will be d by dt of y. This will give you the y component. Now for the x component, what we will do, since the value of x is given to you as ct square as you can see the position of the body to the xy plane. So you can simply differentiate with respect to time this value of x, which is ct², right? When you solve it, c is a constant coming out and d by dt of t². So this will be 2t, because 2 as a constant will be coming out and power of t will be decreased by 1. So this will be c into 2t, or we can say 2ct. So 2ct is the component of x component of the moving body. So that is calculated, right? Now same will be happening with y component, and the value of y is given to you as bt², you can see, right? So let me slightly move it up. Okay, so d by dt, that you need to differentiate the y component. The y component is bt². So just put up the value bt², right? As we did, b as a constant will be coming out, so it will be b, and then d, we are left with d by dt of t², as we did above. It will be b into 2 times t power 2 minus 1, that is b into 2t, so it will be 2bt. So 2bt is the value of the velocity having y component. So here you can see the y component is also calculated, right? Now the question is that the speed of the body. So since we have calculated the x component here and the y component here, then what will be the resultant? Here you can see this will be the resultant, right? If you remember the vector concept. So if this is x, if this is y, this is root over of x² plus y², isn't it? So with that concept, I am assuming that you are knowing it, we can see the speed of the body. That means v can be velocity or speed of the body can be calculated as root over of this dx by dt whole square, because this is the x component of the velocity, right, plus dy by dt whole square. So this will give you the velocity, but we should have calculated and just bring it to its normal form. So just put the value of dx by dt. The value of dx by dt we have calculated as 2ct. So put up the value of 2ct over here and a square of it, right, plus dy by dt. What is the y component of that velocity? Is 2bt, right? So earlier it was dx by dt, the x component of the velocity was 2ct and the y component of the velocity is 2bt. X component we have already written and y component is 2bt. Just write it, 2bt whole square, right? Now this will give you, again changing the pen, 2 square c square t square, that is 4 c square t square, right, plus 4 b square t square, isn't it? And when you further solve it, you can see 4 and t 4 and t square is common. So what we can do, we can write 4t square as common, and inside the bracket we are left with c square plus what, 4t square is common from the second term also, and we are left with b square, right? So c square plus b square will be left into the bracket, and here 4, from this 4 only 1 2 can come out because this is a square root, right? And this t square, if t square inside the root, 1t can be taken as outside this root, right? And we are left with root over of c square plus b square, or just we can reverse it, right? So let's say b square plus c square, right? So this is the speed of the body, this is the speed of the body, that is 2 times t into root over of b square plus c square, and this is our answer which is calculated, right? I hope you understand. 2 times t, 2 times t root over of b square plus c square. If you want me to explain, let me know, I will explain it again. Okay, so here you can see how we have started solving this question. The x component and y component, the coordinates of the body at a particular instant of time is given to you. The value of x was ct square, the value of y was bt square, right? Now the speed of the body need to be calculated. So speed of the body is definitely, it's the component of, at any time t is given, okay, body moving, and at any time ct square and bt square is given. So at any time t, why t? Because you can see the variable over here into the x component and y component is given is t. So that's why at a certain period of time, at a t, but at a time t, x is ct square and y is bt square. So these components at t, that means at time t, right? Now the x component is given to you and y component is given to you. What we did, we simply take the differentiation, we differentiate the x component of the velocity with respect to time. So this give you d by dt of ct square, and when you solve it, you get the x component of the velocity as 2ct, right? So 2ct is the x component of the velocity, right? Now because this xy is the position, you know, this was the position, so then we need to differentiate it with respect to t to get the velocity of that particular x component. So this is calculated as 2ct. Similarly, if we take the y component and differentiate it with respect to t, we get the y component of the velocity of that moving body, so that is d by dt of bt square, which gives you b as a constant came out, and d by dt of t square is left inside, and after that You can see t square can be when we differentiate it with respect to time, it will be 2 into t power 2 minus 1. So this will be 2bt. So the y component of the velocity is calculated as 2bt. Now you can see, if you remember the vectors, if the x component and y component is given to you, then what will be the resultant? It's root over of x square plus y square, right? So here the x component of the velocity is given to you, that is x component of the velocity is given to you. That means here what we did, here dy by dt and dx by dt, if this was dy by dt, right, and this was dx by dt as given to you, then the resultant vector will be this one, right, isn't it? Right, so we simply using the same, we calculated the speed of the body as root over of dx by dt component whole square plus dy by dt whole square, because this gives you the x component of the velocity. So dx by dt, you can see dx by dt is the x component of the velocity and dy by dt is the y component of the velocity. When you take a square root of both the terms after taking a square, that is dx by dt whole square plus dy by dt whole square, taking a square root, you just derive it to a value of 2 times t root over of b square plus c square, right? So this gives you the velocity or the speed of the body at that particular instant of time, what, at t, at t time. So at t time we have calculated v as 2t root over of b square plus c square, right? Sorry. So here I want to clarify it again, okay? dx by dt is, this is the dx by dt, this is the x component of velocity, x component of velocity, right? And this dy by dt is y component of velocity, right? This is the y component of velocity and this is the x component of velocity. So we calculated the value of dx by dt, that is 2ct. We calculated the value of dy by dt, that is 2bt. Here you can see. And to calculate the speed of the body, what we did, root over of dx by dt whole square plus dy by dt whole square, and just simply put up the value of dx by dt and take a square of that. So dx by dt is basically, we derive it as 2 times ct. So this 2 times ct, this one, right, we put it over here, you can see, in place of dx by dt. So it becomes 2ct and you can see a square is there. So we again take the square over here. So 2ct whole square, and dy by dt we calculated it as 2bt. You can see 2bt, right? And in place of dy by dt we put this value of dy by dt, that is the y component of the velocity. So here 2bt In place of dy by dt, we put up this value and take a square of this. And when you solved it, when you just solve it, you can see 4t square is common in both the terms. So that's why 4 and t square, which I have underlined, is taken as common. And we are left with this c square and this b square, right? So c square and b square is left in between, is left over, that is c square plus b square is left over, and this 4 and t square is taken common from the first term, and this 4 and t square is taken common from the second term. So since 4t square is taken as common, inside the bracket we are left with c square plus b square. But when you take the square root of 4 is 2. So 2 will be coming out from this square root, because the square root of 4 is 2. And the square root of t square is t. So that's why this t came out. And inside the bracket we are left with this b square plus c square, right? So root over of b square plus c square will be multiplied with this 2t, and this will give you the v, that is the speed of the body at a particular instant of time t, at t time, right? If you remember, the x component velocity, x component, and y is dx by dt. So that's over here into the x axis, and the y component of the velocity is dy by dt. So that is over here. So the resultant will be this one. So this is v, that is root over of dx by dt whole square plus dy by dt whole square, right? And this is calculated. I think you find it useful, students. It's a very simple question, and concept is covered over here, and I hope you understand it. You can go through the session. Even I have put a shorts of this yesterday, and I will attach this explanation into that shorts so that you can, or anyone can take use of that, and it can be helpful, right? So in the live session I am just breaking the steps very and explaining it, elaborating the things very clearly, right? So that you are able to understand it. Okay, I know many of you are understanding, but the clarity need to be required. Okay, so considering all candidates, all students, I am just explaining it, that some of you who is just starting from a scratch, they will understand the things and build the concept, right? So in this way we have solved this question, and this is the resultant velocity or the speed of the body at a particular instant of time t, at a particular instant of time t, and that is calculated as 2 times t root over of b square plus c square, right? And this is our answer. Thank you so much for watching, students. Take care. Bye bye.